Hi, in this video we're going to talk about the scientific method. So, what is a scientific method? This is the way that scientists approach problems. This is how they solve their problems or solve their questions. It is a very logical way of thinking and it's systematic approach to problem solving. Systematic meaning that it's stepwise, so it goes steps in order. So let's talk about those steps. So the first thing, step one, is purpose. So first, this is what you want to learn. What's your question? What is the purpose? Why are you going to do the experiment in the first place? This is where you create your question. It's going to be a very specific question. Now, be careful because opinions are not good questions. Now, why they are questions, they're not testable. So you can't test what is like the coolest brand of clothing or what is the best flavor of Kool-Aid. Those aren't things that you can test because those are just opinions. But you can test which brand of Kool-Aid is most preferred in a specific group. That you can test. So you have to be real careful when you have that. But once you have a question, you can also double check to see is it really valid by using this format. Does this affect this? I would say 90% of the time, if you can put your question into this format, it's going to be a testable question. Does temperature affect student performance? Does temperature affect the rate a bird flies? Does temperature affect the amount of chirps a bird has? Those are all testable questions, and they can be fit into that format right there. Okay, so once you have your question, then you're going to go to your step two, research. This is where you're going to find information about your topic. You're going to use sources to gather information about your question. You're going to look to see, well, has that experiment been done before? And if so, what were the results? And can you then use it as a launching pad into another experiment? Okay, now once you have done that research, you're coming up with like, oh, this is an experiment I kind of want to check to see in this question I want answered. Well, now you got to think about what's your hypothesis. Step three. Hypothesis is your educated guess about what you think is going to happen in an experiment. You're using information that you already know to make a guess about what your results are going to be. Now, this should be an educated guess, so use that information that you already know. One of the formats that we really recommend using is the if, then, and because statement. If this is done, then this will happen because of this. You think of this as like cause and effect. If I do this, then what's going to happen over here? And then what's your reasoning behind it? Okay, once you have your hypothesis, then you can start designing your experiment. Before I go on, we are going to have another video where I delve into hypothesis and also controls. And so we're going to save like really going into them and doing examples of that into another video. So let's just kind of pause that and go on. Okay, step four. Step four is experiment. You're designing a way to test your hypothesis. The experiment must be designed in order to actually answer your question. You have to keep in mind all of the variables that can affect those results. Every single variable needs to be considered. Okay, let's talk about those variables then. So how do we set it up? Well, you have three main types of variables. We have our independent variable, our dependent, and our control variable. The independent variable, the I for independent, this is the one as I as the scientist am changing. I as the scientist am manipulating that variable. I am controlling what is going to happen. Or I'm controlling what I'm changing and then seeing what happens from that. So this is the one I change. I for independent variable. The variable that changes as a response is your dependent variable. This is the one that is that depends upon that independent. You can think of these as cause effect. Cause is your I, you caused that, and then dependent is the effect. That kind of helps. That's kind of a way I use it. Okay, control variable is all the other variables in experiment that could affect those results, but you are making sure that they're kept the same. So if you're testing something and you want to see if, like, say, temperature affects the amount of bird chirping, then you need to make sure that everything else in that experiment is kept the same. You need to have one independent variable, and then all those other things that could affect the amount of bird chirping needs to be kept the same. So the number of birds in the cage, the number of distractions in the room, the size of the room, the amount of food that it's given. It might be hungry. It might want to start to chirp because it's hungry. The amount of water that's there, whatever. Anything that can affect that dependent variable needs to be kept the same. Now, the other thing is about the dependent variable is that you can have as many dependent variables as you want. So for instance, if you have pharmacists that are trying to come up with a new drug and they're going to treat this group of test subjects with the new drug, but they're not just going to give them the drug and test one thing. If that drug is supposed to test for blood pressure and affect blood pressure, yeah, they're going to monitor blood pressure. But they're also going to see, well, does this drug affect any other side effects? Does it affect the base heart rate? Does it affect the cholesterol, the glucose level, the temperature, the number of blood cells, all the other things that scientists like to look at that make sure that you're healthy need to be kept also monitored. So while they only changed one thing in their independent variable, they kept all the other conditions the same that are affecting that dependent variable. They also monitored a bunch of different dependent variables too. Okay, so once you have your experiment controlled, you got your variables, you might need to divide your subjects into two groups. You have a control group and then you have a test group. The control group is the group that is the same and is getting normal conditions. They're not getting the testable conditions or the testing apparatus or the testing medication. Your test group or the experimental group is the one that gets the medical changing or the different material or the different changing. This is the abnormal conditions. So your control group is your normal conditions. Your test group is your testable or your experimental conditions. Sometimes, rather than having them like untreated versus treated, sometimes your control group is given what's called a placebo. And this is like the medication that looks exactly like the treatment or the pill or whatever medication it is, but it just lacks that one active ingredient, the thing that's actually going to cause the effect. That's what's called your placebo. So like if you have scientists that are giving a drug that they're testing to see, well, does it affect blood pressure or not? They're going to give one group a little tiny white pill that has that active ingredient with the new drug in it, but then they're going to give this other group, the control group, a tiny white pill that doesn't have the active ingredient. And if you look at them side by side, you wouldn't be able to tell which one it is. And the reason why is because there's a thing called the placebo effect. And that's where people could possibly say that they're getting better, they're feeling better, or you get some sort of increase when they actually didn't get the drug. And this is actually a thing. And it's kind of a thought of that maybe it's like this mind over matter thing. Like you think you're going to get better, and so you do start to feel a little bit better, but it has nothing to do with the treatment, that kind of thing. And so it's a way of controlling for that, those inaccurate results, those things that could skew your results a little bit. So once you have your experiment set up, you can do your experiment, and then you can go on and you collect your data into some data tables and graphs. And you're going to do this. You're going to do step 5. You're going to analyze and evaluate. This is where you're going to organize information to figure out what is the information telling me. So you're analyzing. You're looking for mean and median and mode. You're going to look at those graphs and tables and pictures. You're going to look for keyword here, patterns and trends. Is it increasing? Is it decreasing? Are you actually seeing that effect? And we'll talk a lot about how are we actually going to create a good graph and good data table later too. All right, once you have those graphs and you've found those patterns and trends, then you can go to your step 6 conclusion. What are those results actually telling us? Like, what are they telling us that actually happened? Does your results actually support your hypothesis? And keep in mind too that just because we had a hypothesis and we've proved it wrong isn't bad. It can be sometimes just as good as having a correct hypothesis. So because it can lead us into a different area, could branch off. So we need to be open-minded and we need to be wise enough to say, like, I don't have to always be right, and that we're gonna go where the data leads us. Follow what the data says. If the data is telling me I'm wrong, then I was wrong, and it's okay. I thought the way something, but then I'm changing it now that I have new evidence. So that's, again, what is the evidence telling us, and what can we conclude? And also here's where you're going to come up with that why. Why did we get the results that we did? And this is where it can branch you off into a lot of different studies and go on. And you also want to think about, how can I improve this experiment? Where can I go now? What do we need to change, and where can we lead off? Where can we branch off and further explore the content or the questions? That, I believe, is it for the scientific method, steps 1 through 6. So watch the next video and we'll delve deeper into design of your experiment and creating a good hypothesis. Thanks for watching. Be good, be kind, be awesome, and recycle.